Teach me about the Great Lakes. Teach me about the Great Lakes. Cha! Welcome back to Teach Me About the Great Lakes, a twice monthly podcast in which I, a Great Lakes novice, ask people who are smarter and harder working than I am to teach me all about the Great Lakes. My name is Stuart Carlton, and I know a lot about sweating. Lots and lots of sweating. Just rivules of sweat dripping because I can't turn on the air conditioner in my office when I record. But I don't know a lot about the Great Lakes. And that's the purpose of this here show. I'm joined today once again by the one, the only, the special Carolyn Foley, research coordinator for Illinois Indiana Sea Grant. What's up, Full Dog?
I'm all right, thank you. I'm not sure how much I enjoyed that visual, but thank you.
Oh, the review. Yeah, that's probably no good. I know a lot about
You're fine.
Some things, but I don't know a lot about the Great Lakes.
Fine. It is really warm outside right now. So
yeah, just wait. We got an hour-long recording session. By the end, it's going to be... Anyway, Purdue might rethink their policy on how we can't open our windows.
Because you've got sweat dripping on it? Yes. All right. But
bleak.
We're going to be talking about some cooler things that hopefully you'll be able to think through.
Yeah.
Yes.
No, actually, I'm super excited about this because we're teaching, as you know, in the spring, we are teaching a Great Lakes Issues course, right? We taught it last fall, and we're going to teach it again this spring, and I might even accidentally be involved with teaching it. But we're talking to outgoing Illinois Indiana Sea Grant Director Thomas Hook about a potential field course. And he said we need to do it later than we were thinking because we want to give the lake time to turn over. And I said, well, of course we do. And then I went and did some Googling. Anyway, and so we're here today to talk about that, I think, but I'm not sure. But first, let's go ahead and bring in our transition. Researcher feature, a feature in which a researcher gonna teach us about the Great Lakes. Dr. Jay Austin is a professor at the Large Lakes Observatory at the University of Minnesota Duluth, home of Minnesota Sea Grant, and our good friends over at Minnesota Sea Grant. Jay, how are you today? Thank you for coming on.
Doing very well, Stuart. Thanks for having me on.
Oh, yeah, we're thrilled to be here. And so today we're here to talk about stratification, sort of in lakes generally, and then in the Great Lakes specifically. So let's start with that. What exactly is stratification? We know that strata means like layers or something. What is stratification in the context of a lake?
It's exactly that, in that lakes and fluids in general like to arrange themselves with heavier stuff below and lighter stuff above. And so if you look at a bottle of salad dressing as sort of the classic example, the lighter density oil is sitting on top of the heavier density vinegar below. Water density depends on temperature. And if you have water of different temperature, and this is where it quickly gets into the weeds, you can layer water with warmer water above and cooler water below, or as we're going to talk about today in the winter, the opposite happens. If you go swimming in a pond in the middle of the summer, you might dive down into the pond and find cooler water deep in the water column. And then as you swim back up, that warmer surface water. For reasons that I'm not going to go into, or maybe we can, I don't know what level of specificity you want here. In the winter, in lakes that are sufficiently cold, like Lake Superior, you end up with very cold water at the surface and slightly warmer water in the deep portions of the lake.
Okay. Well, let's pull back for a second. But generally, if you have cooler water below, does that mean that the cooler water tends to be more, accepting the winter exception here, does cooler water tend to be denser than warmer water?
Yes.
Okay.
Yes. As a rule for fresh water, water gets less dense as you warm it up. And so in summertime, in most sort of mid to low latitude lakes, you have warm water sitting on top of cooler water below.
And of course, that's because the molecules are zipping around more as it warms up, right? And it creates more. Oh my goodness, I'm going back to third grade and it's all making sense. Okay.
Yeah. And so I think we've talked with some guests on the show about, how fishing, they like to kind of find the spot, the thermocline where the mixing happens because the fish tend to hang out there or their food tends to hang out there. So Lake Superior is, if you go swimming in Lake Superior in the summer, it's typically like 6 inches or something like that. And you're like, oh, I'm cold, right?
Yeah, the thickness of that upper layer varies depending on what sort of meteorology you have. But
Okay.
the offshore work that I do, typically the top 10 or 20 meters is nice and warm in quotes, with water down around 39 degrees Fahrenheit or 4 degrees Celsius in the deeper portions of the lake. And of course, the actual thing that's going on out there is going to be always be a little more complicated than what I say here. But uh, for all intents and purposes, it's maybe 39 Fahrenheit in the deep. Do you guys prefer um,
Oh,
imperial or metric units? Or
whatever
UK?
you prefer.
Ye-
We prefer our
Okay,
guests to be comfortable.
Yeah.
fair enough. I'm a big metric units guy.
So, but then you mentioned that in a deep lake like Lake Superior, the reverse happens where there's very cold water on top and warmer water at the bottom.
And by warmer, I mean about 39 Fahrenheit. So
Right.
still dangerously cold, but warmer than the close to freezing water in the upper layer.
And so how does that happen? Is that because wind makes it blow around, or what causes this stratification to reverse like that?
So fresh water has a really, really bizarre property in that as you warm, it has a temperature at which the density is maximum, and that's around 39 degrees Fahrenheit. Um, Below that, density increases as you warm it, and above that, density decreases as you warm it. And so, I mean, the example that most of us are familiar with is air. As we make air warmer, it gets less dense. That's why we put hot air in a hot air balloon, for instance. That makes it float. If you get into the sort of physical chemistry intricacies of water, it just happens to have this really bizarre property right around 39 degrees Fahrenheit. And so if you're below 39 degrees Fahrenheit, you're going to get that reverse or inverse or winter stratification, depending on who you're talking to.
Oh, that's so weird.
It is, yeah, I completely agree. It's really
Is
weird.
that
I'll
easy
say
to explain why that happens, or?
Again, I could find a physical chemist in the chemistry department here who probably would have a better grasp on that than I do. I'll point out really quickly that my background, my graduate work was actually in oceanography. And every time I go and talk to my oceanography colleagues, it takes a while for us all to wrap our heads around the fact that there's this really bizarre relationship between temperature and density. It is not intuitive at all.
Yeah, it doesn't strike me as intuitive.
But then,
They're sure not intuitive to me. Go, Carolyn.
and does it change really vastly if you're talking about saltwater versus freshwater as well?
Yep, absolutely. Salt water, as you add salt, that temperature of maximum density becomes lower and lower and lower until it reaches the freezing point, in which case water always gets less dense as you warm it. And that's true for the world oceans.
Huh. So then
So
oceans.
there's not an analog to this effect in the world oceans, in saltwater.
And so this has implications, right? Stratification, because the water sort of turns over and mixes. And you are not a biologist or an ecologist exactly, but what does that cause to happen to the various animals and plants and bull sharks or whatever's running around in the lakes?
Yeah, in fact, I for what it's worth, wrote a paper on this about how this affects zooplankton migration a few years ago. And I teamed up with some biologists to make sure I wasn't saying anything really dumb. But the idea is that there are these transition seasons between when it's positively stratified in the summer and negatively stratified in the winter, where the water column is uniform in temperature. And by uniform, it'll be 1/100th of a degree difference over 200 meters of water. Just really remarkable. One thing that's important about those seasons is that stuff in the water, and by stuff I mean phytoplankton, I mean nutrients, dissolved oxygen, whatever parameter you want, ends up being extremely well mixed through the water column. And so you have these very, very weak gradients and properties throughout the water column. Once you form stratification in the winter or the summer, those two layers tend to be distinct from each other. If you are mixing things, you can only mix them over that surface warm layer, or the deep layer would be relatively uniform in whatever property you're talking about. And so the paper that I wrote a few years ago showed that zooplankton that typically migrate once a day from deep in the water to up in the upper portion of the water column, they change that migratory behavior depending on how the water column is stratified. And so it does have sort of like first order biological effects. And I'll put another good ecological example is the reason that you get big hypoxic and anoxic zones in Lake Erie in the summer is because that deep layer is cut off from the atmosphere for all intents and purposes, and you have biological activity that uses up that oxygen, and it doesn't get replenished. Whereas if you have mixing over the water column and that water is in contact with the atmosphere, you don't have that. You don't have those hypoxic events.
So then, the hypoxic events generally they tend to they tend to be in the summer, and that's because there is no mixing going on.
There's no mixing, and there's lots of microbial degradation
because it's warm enough that there's more happening. And
exactly.
So
Superior doesn't have those levels of biological activity. It's a very oligotrophic lake, another fancy word for things don't eat much. But we don't have hypoxic events just because there isn't that rapid degradation in a deep lake like Superior, deep cold lake like Superior.
So with this, so that was a paper you wrote a couple of years ago that we'll add to the show notes. But the one you wrote most recently was focused specifically on winter. And so have you thought, or have you all talked about the implications of the kind of stratification in wintertime? And was it more than just Lake Superior that you saw this in?
Wait, can we back up and introduce this paper, actually? Because I have a few bigger questions and then get into that.
Okay.
So this is a paper just out in the Old Jiggler, Journal of Great Lakes Research, with a couple of former Teach Me About the Great Lakes guests, actually, Eric Anderson and Drew Grunwald. And so it's called Winter Thermal Structure Across the Laurentian Great Lakes. So tell me, first of all, so I guess we didn't know a lot about the winter structure, right? So why did you decide to write this? And then where did you get your information from? Like your data sources and this sort of stuff.
So I feel like I'm a physical limnologist writ large. I work on all kinds of different things, but one thing that I've spent a lot of time thinking about are processes in the winter. It's something that we just don't know a whole lot about, and there are good reasons for that. It's different. You can't get out in a boat in the winter. You can't do it safely, and a lot of the work that I've done has been focused on putting platforms into, in my case, Lake Superior, and leaving them there over winters. And so my group at Large Lakes Observatory has had stuff at a location in Western Superior in about 600 feet of water since about 2005, around the calendar. Second longest continuous record of these sorts of things anywhere in the Great Lakes. GLERL, you mentioned Eric Anderson, but also Steve Ruberg and Craig Stowe are on that paper. Also our colleague Matt Wells up in Toronto. They've had a site in Lake Michigan since about 1996. And so those are the two big, data sets that tell you about what's going on below the surface. We collect a lot of data at the surface because it's easy and we have satellites and stuff like that. But there's so much less known about what's going on below the surface. And that's what really fascinates me, because you have to understand that if you want to understand what's going on at the surface, where we interact with it, where there's ice, stuff like that.
So one point I want to make on that, it's interesting that there's so little data out there, right? And some of that's the difficulty of collecting, but also shows the importance of, this is one of the main themes we've learned talking over the last 100+ episodes of this podcast, is like the importance of these long-term data sets. And a lot of times they're collected by the government. You mentioned GLERL, the Great Lakes Environmental Research Lab, right? And what's nice about places like that, and I'm not sure about the Large Lakes Observatory and the work you do, is it's not as project-based as academic work tends to be, right? A challenge with academic work is a lot of times with faculty members, and I'm one. You go and you get a grant, you do a project, and then you need to move on to the next project. If you can keep something going, great, but if not, you move on. And so these government data sets have a different incentive structure, and they're really, really valuable.
And so I'll point out that the data set that we've collected over nearly 20 years now has been entirely project-based. It's Joe got a grant, now we have a mooring there. Then Jay got a grant, then we had a mooring there. And then Sam got a grant, and then we have a mooring there. Or nobody has a grant, but Dr. Miner is going to be out at that site, and there's an extra bunk, and I'll tag along. And so we have managed to string this along with duct tape and wire ties for 20 years, and it is an incredibly valuable resource.
Yep.
It would be nice. I would love to see it institutionalized, but that's not where we're at.
Right.
No.
And so what type of sensors do you have on these platforms?
All kinds of things. And so the primary thing, and the thing that was the focus of the paper that we're talking about right now, is temperature structure. And we measure that by putting instruments called thermistors, it's a fancy word for a temperature sensor, and we attach them to a steel cable. So we have an anchor that sits on the bottom of the lake. We have a piece of steel cable that goes up to a subsurface float that sits about 10 meters or 30 feet below the surface. And then we bolt these thermistors at various depths, from as close to the surface as we can get all the way to the bottom. And so in some years we might have, I don't know, a dozen of these at different depths. For a couple of years, because I was very interested in vertical structure, we had 90 of these thermistors.
90? Oh my gosh.
That was a lot of work. Just downloading it, everything took a day or something like that. So, but you can ask different questions with a data set like that you can't with just, a dozen thermistors. We also have instruments called acoustic Doppler current profilers that measure currents. I've used the backscatter information from ADCPs to look at zooplankton migration. We have a platform funded by the Great Lakes Observing System, GLOSS, shout out, for what we call the Lake Superior Ecological Observatory. And so not only do we have a big array of thermistors, I think we have 60 at that site right now. We have a pair of these Doppler current profilers. We have another one that's acting strictly as an echo sander, giving us high vertical resolution images of zooplankton migration. We have sediment traps and sequential water samplers. We have a water quality platform provided to us by Rayon over in Windsor. And so all of that is at that one location. It has been there since last August.
Is this the same place? Way back in episode 60, we spoke with Rosalind Putland about her research on the soundscape ecology. And I just pulled up her paper, A Song of Ice and Vessels, and noticed that you were the second author on there. So worlds are coming together.
Yep, and I actually have an undergraduate student working on expanding some of that acoustic work this summer.
That's really cool.
So,
that's really cool. Okay.
Yep, sure.
All right, so let's pull it back into the paper, although I could talk about data nerd stuff all day. But so this strikes me, when I saw the abstract to this, I was like, this is weird that we don't know anything, or we don't know very much across the Great Lakes about their stratification in the winter, right? So this strikes me as a pretty major effort.
Yeah, and I will admit, and I don't let my co-authors hear this, but I wrote this paper out of a sense of frustration at some level that there was all this really great data out there that really had not been exploited. We're all busy people. And what I really wanted to do was something comprehensive. And so GLERL had data from Michigan, Huron, and Superior. I have a lot of stations across Superior over the last 20 years. And then Matt Wells provided some data from Lake Erie in Ontario. The Erie in Ontario really only started in about 2021 or 2022, so we have very little data so far from those lakes. The Michigan, Huron, and Superior data really formed the core of this paper. But yeah, you're right. A lot of the stuff isn't out there. If somebody asked, does Lake Michigan form inverse stratification in the summer? There wasn't a good paper out in the literature to address that question, which just really struck me as a sort of a big knowledge gap.
Okay. So what did you find? And so acknowledging that you had a much stronger data set for Lake Michigan, Huron, and Superior, what kind of findings did you see? And was there anything that really surprised you? Was there anything that really surprised you?
Yeah, no, I mean, I'm still really excited about this particular paper. What we found, first of all, is that the lakes behave very differently. Superior, at the site that LLO has been at, LLO Large Lakes Observatory, the site we've been at since 2005, every year we have data for, it stratifies. Some years it gets cold enough that it forms ice at that site. Lake Michigan, at their deep site, or at their site that they've had since 96 or 97 or whatever it is, never stratifies. Unfortunately, their mooring failed in 2014, which was the polar vortex winter. And so I suspect that it stratified at that site in that particular year. But the years they have basically never forms stratification. Lake Huron goes back and forth and stratifies in cold winters and doesn't stratify in warm winters. And so I find it fascinating that we have these three lakes that are not horribly geographically distinct from each other, that really have these very distinct behaviors. This was initially just meant to sort of be a survey of what was out there, but my colleague Matt Wells up in Toronto pointed out that a group at GLERL, led by Ayumi Fujisake Nome, recently put together a database of daily sub-basin air temperatures across the Great Lakes that dated back to 1897.
Oh, wow.
And so, about 120 something years of air temperature. And what we were able to do is use our understanding of modern processes, combine that with Ayumi's work to hindcast, to make a guess at how these lakes stratified for the last 100 and something years. Go ahead.
Oh, no, that's just fascinating. I was just excited. I started leaning forward, listener, because I got so excited to think about that and what that could even enable, just in terms of our understanding. And
so what we found, I think this is the most telling part of this whole story. I think the real hook is if we only had the modern data, the mooring data from GLERL and from LLO, we would say, yeah, Superior always stratifies, Michigan never stratifies, Huron bounces back and forth. But Huron bouncing back and forth is a relatively modern phenomenon. It's only in the last 10 years or so. And if you go back before 1998, it always stratified. Michigan, we might say, oh, it clearly never stratifies. But if you go back 20 or 30 years, there are plenty of years where it's stratified. In cooler years, 50 years ago, it would stratify. So what we're seeing is this progression from, one state to the next warmer state. And without Ayumi's big 100 and whatever year time series, we'd have a very, very hard time understanding that. And this gets back to your point, Stuart, about needing long data sets. You go out and have a 3-year grant to study something, you really can't say anything about long-term change. And so these long-term programs are really very valuable.
That's amazing. And so the source of those changes, that's just climatic differences? Is that kind of big picture what it is? Or
it's climate change. The air is warming up.
Yeah.
The lake responds to that. It turns out that almost all of the variability from year to year you see in the thermal structure, how cold a lake or how warm a lake is in the winter, almost all of that variability can be attributed to whether you're having a warm winter or a cold winter, which is not rocket science, right? But it is remarkable to me how much of the variability can be explained in terms of that one variable. You can just average the air temperature from December through the end of February, and I'll tell you, I can, with a very high degree of accuracy, tell you, or of certainty, what a lake did that winter.
That's very cool. And so the moorings that you're looking at, though, they're all in relatively deep water. Is that correct? Am I understanding that correctly?
Yes. Yeah. So the long time series that I use from Superior is a site that's about 185 meters. That's about 600 feet deep. The Michigan site that GLERL maintains is in the southern basin, which is not as deep as the northern basin, but it's what we have.
Right.
So, but yeah, we are not looking at coastal sites, and the reason is that coastal sites tend to be complicated by lots of other dynamics, and so I prefer the way offshore, super boring, very, very, flat bathymetry. So I don't have to worry about all these complicated effects. I can think of it in some reasonably one-dimensional sense.
Right. Yeah. And that's what I was thinking too. I tend to hang out more with my research along the shorelines and stuff like that. And I was like, I bet it would be a mess and really interesting. But, and you said, very boring, but evidently the offshore is not boring in this case. It seems like you're finding lots of
I just mean that you remove some complications by moving out to these big flats. The irony is that my graduate work was actually on coastal upwelling.
Oh, right.
And so I was a coastal oceanographer, and now I'm probably, if not one of the most offshore person working in the Great Lakes right now. So as far as this instrumentation goes.
That's very cool.
Excellent. And so thinking about this, so now we have these data sets, and you've done this sort of summarizing work, right? So we have a better understanding of the winter stratification across all 5 Great Lakes. What does that enable going forward? Now that we have this, or now that we have this new knowledge, spin it forward with me. What does that tell us in the future, or what are the next steps? That sort of stuff.
Yeah, so I do this because I'm curious about how the lakes work, not because I'm trying to advise policy or something like that. But one thing that I pointed out is in Lake Michigan, there are some years where in this instrumental record, where it has come very close to not having a period of winter mixing. In other words, you're stratified in the summer, and that stratification reduces, and all of the records we have so far, there's a point at which it collapses and things mix well, and then it starts forming stratification the next summer. There are years where that period where it's mixing are really short. And again, not a biologist, staying in my lane, but if you don't have that mixing, that's sort of the next step up in this hierarchy of how lakes stratify. And it means that you're trapping that deep water and never exposing it to the atmosphere. And so that is going to have significant long-term ecological implications that I'm sure you can find guests more capable of discussing. But
Sure.
It's a little bit worrisome. The other thing that somebody pointed out to me, and I think this is a good idea, is that we could take our understanding of how these systems work and use, what are called representative climate pathways, or RCPs, to make forecasts. Like, when is that going to happen to Lake Michigan? What year can we expect the first year where it doesn't destratify in the winter? And is Lake Superior going to get to the point where it doesn't form winter stratification? And so I think there are a lot of interesting things we can do along those lines. The project that I've been talking with that long list of co-authors about is understanding one thing that GLERL does really well. They do a lot of things really well. One thing that they do really well is modeling, numerical modeling of the Great Lakes. And I'm sure you've had people on at one point or another to discuss sort of the concept of numerical modeling. What we want to use this data set for is to understand how well those models are working in the winter. So that's the next step for us.
Cool. And are there other, so they had, I don't think we had anybody on to talk about this, but I know a couple of years ago they had the Great Winter Grab, or whatever they called it, where a whole bunch of different groups went out and collected winter data all at once. Are any of things like that, could those be used to kind of ground truth what the
So I'll put in a plug that the Winter Grab is organized by my colleague Teddy Ozerski here at the Large Lakes Observatory. So he'd be great to have on sometime. Good guy.
I'm writing it down now.
And the Winter Grab is largely a coastal thing. It's where people can get to in the winter. And so I'm not aware of particularly many offshore sites that they're sampling. I'm hoping that the work that we're doing out at our western site that we did this winter, I had that sort of laundry list of stuff that we left out there since last August. I'm hoping that sort of thing can help to inform the Winter Grab by providing some sort of offshore context to what they do.
Very cool. Very, very cool.
Well, this is really fascinating stuff to hear about. And actually, I didn't think I could talk about mixing and stratification all day long, but I could. And I really, at some point, want to go deep on all this technology. I think there's a lot of stuff to think about there. And it's really neat how everything is, and we haven't even begun talking about AI stuff and all the big modeling that you can probably do as a result of it. Anyway, the point is this. First you need the data.
You need to train on something.
Yep. Yeah. But it's just, anyway, Great Lakes has big data, and that's just a fascinating thing. Because right now there's a big movement at Purdue towards digital forestry. There's a big group here, and it's all great. They have a cool slogan. Their slogan is, "We're going to count every tree in the world," which is a nice big picture, right? Sounds good to the layperson. But man, we got big data on the lakes.
I remember. So my son is a journalism student in DC, and one of their assignments was the professor told them, go out on the quad and count the trees. And everybody came back with a different answer. And his point was that you have to be very careful with how you ask a question.
There we go.
If you want accurate answers, because what is the quad? What counts as a tree? Those sorts of things. So my only tree counting story.
That's a good one, and I think it's especially relevant in these modern days, so I appreciate that. But my point is this. That's not actually why we invited you on Teach Me About the Great Lakes this week. The reason that we invited you on Teach Me About the Great Lakes is to ask you two questions, the first one of which is this. If you could choose to have a great donut for breakfast or a great sandwich for lunch, which would you choose?
Stuart, I'm going to go with the sandwich. I'm not a breakfast pastry guy. I do love a good bagel, And so you could get into the sort of existential argument about whether a bagel counts as a sandwich, I suppose.
Yeah.
Or does it count as a donut?
Or does it count as a donut? Well, it's clearly not a donut.
That's not a hard argument there. No.
I would
right.
say I'll take a good cold cut sandwich any day.
There we go. Fantastic. And so I'm going up in Duluth. And so we know that in Duluth, one excellent place to get a sandwich is the Duluth Grill. And the reason we know that is because Rosalind Putland told us about it. However,
Okay. Yes.
if I'm going to ask you, where should I go get a good sandwich when I visit John Downing up in Minnesota?
Oh, well, make sure you drop by and say hi if you're up here.
Yeah, I will.
I have a completely uncontroversial answer for that.
Okay.
And that's Northern Waters Smokehouse. It's a local charcuterie, which means they do fancy meat, but they do just fantastic sandwiches. So Northern Waters.
Northern
I'm
Waters.
not getting paid for this promotion. It's,
Excellent. Hold on. I'm seeing. Have we got Northern Waters before? Anyway.
No, I don't think we have. Oh, it's a smokehouse as well.
That's what reminded me.
HAUS. Yeah, and so they're down in Canal Park.
Cool.
It's a favorite. It's my favorite.
And what's the best sandwich to get there?
The Sitka salmon. It's a smoked salmon sandwich.
It was recommended to us. The Northern Waters Smokehouse was recommended to us by Lake Superior itself. At one point, we interviewed the person behind the Lake Superior Twitter account.
You're not going to let me know who that is, are you?
No, I'm not. And they recommended the Northern Waters Smokehouse.
Yep.
So,
Yep.
Two-time recommendation. That's done.
Yep.
Me and John Downing will liaise there. It'll be fun.
Right.
So the second question we have for you is, what is a special place in the Great Lakes that you'd like to share with our audience, and what makes it special?
So I think one of the really fun things about, I do a lot of work on our research vessel, the Blue Heron, which is the largest academic research vessel on the Great Lakes. I think it's still the only one that works 24/7. We'll hopefully see that change the next few years. There are a couple groups who are looking at getting larger vessels. But if you're out there 24/7, weather still happens. And when weather happens, you have to turn tail because it's not just uncomfortable, it can be unsafe to work depending on what you're doing. So I remember one time when we got blown out, we were working in Canadian waters, and we were just up about as far north as you can be in Lake Superior. And we ended up having to hide in the Slate Islands. And you will have to check a map to find the Slate Islands. They're as far north as you can get. You get in there, and it's just this beautiful forested islands. We had permission through the State Department to be in Canadian waters. So we do everything. If we're sailing in international, not international, if we're sailing in Canadian waters, we have to get permission through the State Department from the Canadians to be there. We had permission to be in their waters, to put stuff in the lake up there, but we did not have permission to step ashore. And so we sat 100 meters offshore for like 2 days waiting for the weather to be a little more agreeable. But it was really a really pretty place to spend a couple days. And we've been blown ashore in the Apostles, down in Munising. And so I feel just really lucky that I've gotten to see so much around this particular lake over the last several years.
Yeah, these places, the Slate Islands are amazing. I'm looking at pictures now. Just
remote. Yeah.
Wow.
Yeah, my understanding is there are some outfitters that'll get you out there out of Thunder Bay, but I don't think they do a huge amount of business there.
Well, Dr. Jay Austin of the Large Lakes Observatory at the University of Minnesota Duluth, thank you so much for coming on and teaching us all about the Great Lakes.
That was a lot of fun. Thanks for having me on, Carolyn and Stuart.
That was cool. That was fun to talk about winter sampling, winter stratification, Lake Superior.
Wait, so I didn't ask him. Oh, shoot. So does this mean, because we're supposed to hold off on this field course until the summer, but if Lake Michigan isn't stratifying...
No, it is. It's the turnover, yeah. And it's, you want to wait late enough. So I've spent a silly amount of time looking at the graphs on the buoys that we collect. You can kind of see it set up, and then you can see where it's basically like the same temperature from top to bottom, and then you start to see it come back. And then we've actually at times when we've left it out long enough, we get to see the flip over too, the turnover, which I think was one of the things you first started.
I love a good flip
and
over.
you're not talking about delicious pastries.
No.
So talking with Jay Austen there, I was thinking back about our draft that we had for real-time monitoring equipment or things like that, observation equipment. And it included Caitlin Johnson from Rayon, and that was one of the organizations that she mentioned too. So we've interviewed a number of people from the Great Lakes Environmental Research Lab, but then it's cool that we're connecting a bunch of things that we can put into the show notes. Teach Me About the Great Lakes is brought to you by the fine people at Illinois Indiana Sea Grant. We encourage you to check out the cool stuff we do at iiseagrant.org and at ILIN Sea Grant on Facebook, Blue Sky, and other social media.
Our senior producer is Carolyn Foley, and Teach Me About the Great Lakes is produced by Megan Lake Lover Gunn and Renee Miles. Ethan Chitty is our associate producer and fixer, and our coordinating producer is Motia Gumbiade, who I remember to include in the credits. Our super fun podcast artwork is by Joel Davenport, and the show is edited by Sandra Svoboda.
If you have a question or comment about the show, like, hey, it's fun that you're making episodes again, please email it to teachmeaboutthegreatLakes@gmail.com. You can also leave a message on our hotline at 765-496-IISG or 765-496-4474, or you can send us a postcard, because we love postcards. You can send it a lovely picture of wherever you are at in the world.
Or just send us a sandwich.
Well, but the sandwich might go bad in the mail.
But it also might go good.
Thanks for listening, and keep grading those lakes.